everyone. Today we will solve some tasks on design patterns. So the first task is to implement singleton to manage application configuration. So in the application you need to create configuration manager. So we have a configuration manager class. Let's go and create that. Let's create a new class, configuration manager. So it has database connection parameters like database, URL, username, password, path, and logging settings. And the configuration manager class must be implemented in the singleton pattern so that the application has only one instance of this class that will provide access to the configuration data. Alright, so we have fields like private db URL of type string, of course. Okay, then we have private username and password. DB URL, username, password, right? Alright, and it must be a singleton. So to implement singleton, first we need to have an instance of this class, configuration manager. Configuration manager, say config, or config, doesn't matter. Then the constructor must be the type of the access modifier must be private. So private configuration manager. Alright. Configuration manager. And we need to have a method that will provide an access to this constructor, to the instance of this class, since it's a singleton. So a method that will return an object of type configuration manager. Let's call it alright, so say get instance. Let's call this method get instance, and we check if the instance is equal to null. If the instance was not yet created, then we will return new configuration manager. Otherwise, it means the instance was already created in the past, so return the instance itself. Alright, so now let's initialize the fields. So db URL, this will be our URL, username, let's call it root, and password, let's call it password. Alright, so now And one more thing, in order to access this field without creating an object, we can simplify it and use static. So this is a static field, and this one is a static method. Alright. Now what we need to do, we can go to the main class. Let's create a main class. Main. Alright, so now we create an instance, or let's say configuration manager. Let's call it just manager. And instead of creating an instance with the keyword new, we will refer to the method getInstance. So configuration manager getInstance, like this. And next we'll call manager. I guess we need getters, so let's quickly generate some getters. Right, so manager, now we can access password, let's say URL, password, and username. Alright, let's run this. So we have our URL, root is the username, and this is the password. Alright, let's move to the next task. Again, we need to use singleton to create a logger that will log events. The class should provide centralized access. So it should record information about the events, errors, and warnings. The logger class must be implemented according to the singleton pattern. Alright, so let's create a logger. So logger, it must record information about events. Alright. So first of all, we create, let's initialize the field of the type logger. So private static logger instance, let's call it instance. Alright, then we have our constructor, which is private, so private logger alright, and then we have our method, which will provide an access to our constructor, to our singleton, to our object, public, and returns an object of type logger, get instance. Then we have our if statement, if the instance is equal to null, then we return a new logger, else to return the instance. Okay. So here we can print some message, something like logger was initialized. And what else do we have? We need to record information about events, errors, and warnings. So let's create public void error. So we have an error. If we have an error, then we'll print out error. And the message. And the same for the warning. And events. What type of event? Something like database connection was successful, and etc. Alright, and let's not forget to put a static here. And let's test what we've got. Let's initialize logger. Again, we refer to the method get instance. Okay. Then we can call the error log. Let's say what? Error, warning, and events. Exception. Null pointer exception. For event, let's say database connection successful. Okay. And for warnings, for error, exception. Okay, this is actually an error. Error, null pointer exception. And for warning, let's say what? The method is deprecated. Okay, let's run this and see what we've got. Logger was initialized, null pointer, database, and etc. Okay. And now we move to the next task, which is factory method. We need to create a system that will create different types of vehicles, such as cars and bicycles. Instead of having the code depend on specific classes like car and bicycle, we need to use factory method to create objects. This will allow us to expand the system by adding new types of vehicles without changing the existing code. Okay. So Let's create a new class. Vehicle. Alright, so let's create a new package. Let's call it factory method. And let's create a new class which we'll call bicycle and car. So let's first create a transport interface. Transport, it's an interface. Alright, and then we have car factory and bicycle factory. Bicycle factory. And we have specific car and bicycle classes. So car and bicycle. Okay. So transport is an interface, and it will have a method create transport, or just create, and car factory will implement the transport, and here actually it should return actually let me get back, redo all the changes. Alright, so then we're gonna have now another class, or to be more precise, interface transport factory. So transport factory will have a method that will return transport, create transport. Okay, and car factory implements transport factory, and here will return a new car. Okay, so car implements transport, and bicycle implements transport. Okay, the same thing with the bicycle factory, so it implements transport factory. Then we have to return new bicycle. Okay. Now for transport, let's say it has a method void move. Okay. let's print out some message. So car drives, or let's say driving a car. Here let's print out riding a bicycle. Okay. Now let's create a main method. So here we will create a transport factory, say car, new car factory. Let's say car, create transport. Let's call it actually car factory. So this is a car factory. This one is also a car factory. And we create transport. And then we say move. Okay, now let's create another transport factory for bicycle. Bicycle factory. New bicycle factory. So bicycle factory, create transport. And move. Let's run this. So driving a car, riding a bicycle. Or to save this as an object, we can do it like this. We can have a transport car. So now we have a car. We can call car move. And here the same. So transport is the type of the object. Bicycle is the object itself. And we call bicycle move. Alright, let's move to the next task. So in the next task we have to implement factory method for weapons, sword, bow and pistol. In this task we need to create a system to create different types of weapons in the game. So all the weapons have a common interface, but the specific implementations of the weapons will vary. Okay, so what do we need? We need to create a method first of all, we will create an interface weapon, then we will have sword factory, have gun factory, and bow factory. Okay. And we need a weapon factory. Okay, so and we'll have a class game. Alright, so now weapon. Let's start from weapon factory. So weapon factory will be an abstract class with an abstract method. public abstract create weapon. The return type will be weapon, like this. Alright, now the sword factory will extend the weapon factory. Now we need to provide an implementation to the create weapon. So here we will return a new sword, which we didn't create. Okay. Let's create sword. Sword, gun, and bow. So these are the concrete classes. Here in the sword factory, return new sword, which implements the weapon. Alright. Now when we go to the gun factory, we extend the weapon factory and provide an implementation to the method create weapon. So here again we return a new gun. Okay. And gun implements weapon. And bow implements weapon. Bow factory extends weapon factory. Here we return new bow. Okay. Now let's go to the weapon interface. Here we'll have a void attack. Attack. Attack method. Okay. So now we need to give an implementation to the attack method. So we'll print out attacking with sword. I'll print this, I'll copy this message. And here, attacking with the gun. Okay, here, attacking with a ball. Attacking with the ball. Okay. Now let's go to the game class and let's create a weapon factory. Actually, we cannot create a weapon factory. Let's create a sword factory. New sword factory. The same for the rest. Gun factory. New gun factory. And ball factory. can call okay, so let's create a sword. So a weapon, sword factory, create weapon, and weapon, gun factory, actually gun, then we go to gun factory and create weapon, and the last but not least is a ball factory, create weapon. Okay, now we can use sword, so let's create an entry point, main, and let's move all of them inside. Okay. So now we can call sword attack, can call bow attack, and gun attack. Okay, let's run this. You can see attacking with a sword, attacking with a bow, and attacking with a gun. Okay, let's move to the next task. Which is abstract furniture factory. So we need to create a furniture store. So a furniture store offers two styles, modern and classic. Okay. So let's create abstract factory. Let's start from furniture factory. So this is a class. Then we have the modern furniture and classic furniture. So modern furniture, classic furniture. Then we have chair and table, chair, this will actually be an interface. So this is chair and table, interface. Then we'll have modern chair, modern table, classic chair, classic table. Okay, let's rename this into modern furniture factory. Furniture factory. Same here. furniture factory. Okay, so what does it do? Furniture factory is actually an interface. Okay, so let's first go into chair. So chair and table will have methods like sit on for chair, and for table we'll have void use. Alright, now we move into modern chair. Modern chair implements chair. Okay, and we need to implement the method sit on. So let's say sitting on a modern chair. Let's copy this. Okay. Modern table implements table, and let's say using a modern table. Okay. Classic chair implements a chair. Sitting on a classic chair. Okay, and then we have classic table. Implement table. Here we're gonna print out using a modern table, using a classic table. Okay. So what do we have now? Modern furniture factory and classic furniture factory. So furniture factory will have methods. So this is create chair, to return chair, and table. Create table. Alright, now we move into the modern furniture factory, which implements furniture factory. Now we provide implementations to the methods. Create chair, which will return new modern chair, and here for table we'll return new modern table. Okay, and the same for classic furniture factory. We implement furniture factory. Here we return new classic chair and new classic table. Okay, so now let's go into main method. Let's create a main method. Main. So what do? We create so we need to create furniture factory. Furniture factory classic classic furniture factory, then classic create chair. So let's put this into a chair, classic chair. Let's create classic table. So classic create table. Okay, and then we can call classic table dot use and classic chair sit on. Let's run this. Alright, let's move to the next task. So this is for furniture. Let's put it inside a package. So new package, furniture. Okay, let's create a new package, which we will call GUI. Okay, so now we need to implement an abstract factory of graphic elements. The app should work the same on different platforms, but look different according to the styles of each platform. So we need to create different graphic elements like buttons and windows and menus that will look different depending on the platform. So what do we have? Windows and macOS factories. So Windows factory, Mac OS, let's say Mac factory. Mac factory. Then we have menu, button, then we have window, and we have window factory, button factory, menu factory. Okay. And let's create another GUI factory. So this will be an interface, okay, that will have methods like button, the return type create button, and we have window create window, and menu create menu. Alright, so Windows factory will implement GUI factory. Now we provide implementations to these methods. So new button, actually there should be new Windows button. Yes. Let's get rid of this menu, window and button. Okay, let's not delete them. Just let's create another class which we'll call Windows button, Windows menu, and Windows window. Then we have Mac button, Mac menu, and Mac window. Okay. So here in the Windows factory, return new Windows button. And Windows button must implement button. Where's the button? Menu is an interface. Button is also interface. Window, another interface. Okay, so now we move to Windows factory. So for window, we return new Windows window. Windows window. Okay, let's go back to Windows factory. So now we create menu. So we call new Windows menu. Windows menu. Okay. So Mac factory extends GUI factory. The same logic here. So for Mac factory, we return new Mac button, then Mac window, and Mac menu. Okay. Yes, it's an interface, so we implement. Now, what's left? let's remove this. Window factory, menu factory, and bottom factory. We don't need this abstract, these factory methods, since we're using abstract factory. So now we have menu, Windows button, Windows menu, Windows window, Mac button, window. Okay. So menu will have a method. Let's call it render. Okay. And the rest. These will also have the same method render. Copy it and paste it here as well. Okay. Now let's implement. So we print out rendering Windows button. Okay, let's copy this. Rendering Windows menu. Okay. Rendering Windows window. So here, let's print out rendering Mac button. Here, rendering Mac menu. And here, rendering Mac window. Alright, so what's left? Now we need to create a main method. So let's create a main method. Main. So GUI factory Mac. So we call Mac factory. So now let's create our platform operating system. Let's assume that it is Mac. Okay. Then we have our if statement. So if platform equals to Mac, then we'll create factory Mac factory. So our factory will be Mac. Else if it's Windows, so if it's Windows, then it will be Windows Factory. And else, in the worst case scenario, we'll throw new illegal argument exception. We'll say invalid operating system. Alright. And then we can create our button. So factory create button. Let's call it button. And we have the same for menu. Menu. Factory create menu and window. Alright. And in the end we can call this button render, menu render, window render. Let's run this. As you can see, it's Mac. If we would say Windows, then it will be Windows. Now it's Windows. Okay. Let's move to the next task. Which is Builder. So we have an online store. We need to create orders in an online store. So customer can place an order by adding products, specifying a discount, and choosing a payment method. So let's create a new package, builder. So we will have order builder. Okay. And then we have class order. So we have fields like discount and payment method. Okay. Let's create getters for this. also we need to have a list of items. Okay. Now let's generate a constructor. Alright. So we have our order builder class that will provide methods for adding products, applying a discount, and choosing a payment method. So first of all, let's create order builder. So we need to have methods for adding objects, applying a discount, and choosing a payment method. And it should return the builder itself. So order builder. Let's start from adding the items, adding the products. So let's say add product. Okay. In the parameters we specify the product. Actually we need an order itself, so you will have order, and we don't need these fields since we'll be building them, so let's remove. Alright, now to add product we need to refer to the items, so order items, and to access it let's change the access modifier to protected. Now we can access items, add product, and return the order builder. Now we need a method for applying a discount. Apply discount. So we have our discount. Then we go to order. Let's create setters. Okay, so we call set discount, and this one, and return new order builder. And for payment method, set payment method let's call order set payment method and return new order builder. All right. In the end, we need to have a method that will return our order. Actually, the order that will be built should return our order. Okay. Now we need to create a shop class that the builder can use to create orders. So let's create a shop class. Now let's add products. Let's say laptop. Okay, let's add one more. Let's add mouse. Let's add keyboard. Apply discount 30 something, and payment method and let's say credit card. And in the end we built, and that's it. So this is our order. Let's overwrite the method to string. Okay, let's create a main method right here. Let's actually put this into a method. So we'll have public void create order, return order, Okay, so we have our shop, then we have our order. So order is equal to shop create order, and then we can print out our order. Let's try to run this. So we have null pointer exception. Okay, let's see the cause. The problem is, I think that we return every time the new order builder. Instead, we should return the same builder. So let's go and change this. Now it should work. Let's run this again. Okay. The problem is we have an order, but we didn't initialize it, so let's create a constructor. That will return new order. Okay, now it should work. Let's run this. Now we have items laptop, mouse, keyboard, discount 30, and payment method credit card. Yes. Let's move to the next task, which is a character. So we have a game. The player creates a character by setting their stats such as health, damage, armor, and magic. The builder pattern should help us with the creation of a character, allowing us to set parameters and stages without overloading the constructor. So, let's create a new class and a new package. New package. So so what do we need? We need a character builder, and we need a character itself. So character. We need class game. We need class character builder. Okay. So first of all, let's define the fields for our character. We have character health, damage, and armor. So character health, integer, health, private, integer, damage. And we have armor, and magic. So let it be a string, magic. Okay, let's overwrite the method to string. Okay, now let's move to the character builder. So here we'll create, so first we'll define the character. So character, then we'll use a constructor. Let's declare constructor, public character builder. Alright, so now we need to be able to set the health, damage, armor, and magic. So let's start from health. So public, return the same, return the builder. So then we say set health, set health. So what do we need? We need setters. Let's generate setters for all of them. So character, set health. We need to pass health, and return the builder. Now let's have character builder set damage, then we call again character, set damage, the damage, and return the builder. Okay, the same with the armor. Character builder, set armor. So we have armor. Let me say character, set armor, and return this builder. And last, magic, public character builder, set magic. We pass the magic and then change it and return the builder. Okay, and in the end we need to have the method build that will return the character. Alright. Now let's move to the game class. Let's create a method, create character. which returns a character. Alright, so we return new character. Set health to 100. Set we need to return a character builder here. Character builder, and we set damage, let's say 30, and we set magic, let's say fire, and we set armor, say silver, and build. Okay, let's create a main class. So let's create a game first. New game, and let's create our character. Call game, create character, and then we can print out our character. Let's run this. So we have our character, health 100, damage 30, armor silver, and magic fire. Alright. Now let's move to the next task. We need to create an adapter for working with PDF and doc files. So a PDF file, we have two types of files, PDF and doc. PDF file should be processed by the system, but it only works with doc. It's necessary to create an adapter that will allow you to work with files of both formats, converting them if necessary. The task is to create an interface that will accept files with PDF and or doc extension, as well as an adapter that will convert one format to another. So let's create a new package adapter and we need to have a document processor, and we have PDF processor and doc processor. So document processor is an interface and PDF processor implements the document processor. So here we have a method process. Okay, so we print out message processing PDF let's put some string file path. Processing PDF The same for docs, so implement document processor. Yeah. So print out processing doc file path. Alright. Now we need an adapter. Let's create an adapter. So document adapter. So let's first define the processor, document processor. Alright, so then we have our if statement. So if yes, but first we need to initialize the constructor. So document adapter pass in the string type, so type of a document. Then we compare if the type matches equals ignore case. If it's Mac, then the document processor will be initialized as doc. So this becomes a doc processor, and else if type equals to the PDF, then document processor is initialized with the PDF processor. Okay. Let's also implement the document processor and print out processing in the file path. Okay. Actually, now we can refer to the processor and call the method process the file path. Okay, and let's create a main method. So here we have document processor. Let's call it file should be new document adapter. And the type will be let's say PDF. Okay, let's create one more. So the file path will be file PDF. Okay, let's create one more. I will just copy this one. Say file 2. The format will be doc. Let's run this. Alright, let's move to the next task. So the next task is miles to kilometer conversion adapter. So the project has a system that works with mileage units, but the new system must use kilometers. So you need to create an adapter that will convert miles into kilometers. So the new system can work with them without changing the logic. So let's create a new package. Mileage. So we need to have miles to kilometer, miles to kilometer adapter. What else do we need? We need class miles, class kilometers, and main class. And distance. Interface distance. So distance will have method get distance. Okay. Miles will implement the distance. So let's have a private double miles field. Okay, then we have a constructor. Miles. And here return miles. Same with kilometers. So we have private and double kilometers. then we have a constructor, and then we return kilometers. And in the miles to kilometers, kilometers adapter, what we want to do, we'll have a private field double distance. Okay, then we'll have a method public that will return double convert. So here we have a double distance and return. So we need to convert from miles to kilometers. So this is miles. Return miles times 1.6, and we get distance. Miles 1.6. Let's actually use it as an instance of distance. So it will be miles get distance times 1.6. Alright. So let's actually implement a distance here as well. Implement a distance, and instead of convert, this will be our get distance. Overwrite. Alright, let's move to the main methods. Let's create miles. And let's use miles to kilometer adapter. let's print out the distance in kilometers. Okay. Now let's move to the next task. So I need to create a facade for door control, open, close, lock. There are several operations in our system controlling door, opening the door, closing, and door locking. Each operation is implemented in its own class. The task is to create a facade that will combine these operations and provide a simple interface. Okay. So let's create a new package, which we'll call facade. Facade. So let's create a class. Door open, door close, door lock, and door control. Okay, so let's start from the class door open. So it has a method open that will print out the message. The door was opened. Now here I have a method close. The door was closed. Here so we'll have lock and we'll print out the door was locked. Okay, now we go to door control system. Let's create a main method. This is our facade class. Let's rename this into door facade. So we have private door opener, private door closer, and private door locker. Then we'll have our constructor. So public door facade. And we'll initialize our opener, new door open, closer, new door close, and locker, new door lock. Okay, and we'll provide methods. Open door, what we'll call opener open, public close door, what we'll call closer close, and public lock door, where we first close the door and then lock the door. Okay, and now let's create a main method right here. So we create our facade, door facade. Okay, and now we can call facade open door, facade lock door. Let's move to the next task. Facade for smart home. The smart home system has several devices that control light, air conditioner, security system. The client needs to provide a single interface to control all these devices, hiding the implementation details of each of them. So we use a facade to combine all these operations in one interface. So we have light, air conditioner, and security system. So let's create a new package, smart home. So I'll have light, air conditioner, and security system. Okay. So light has a method turn on, turn off. So let's print out lights on, lights turned on, and lights turned off. Okay, so the same here. Actually, I will just copy this one. This is the same. AC turned on, AC turned off. Okay, and the security system. Security system is on, and security system is off. Alright, let's create the facade. So we declare private light private air conditioner, so AC, and private security system. Security system. Okay, now let's create a constructor. Smart home facade. Light is equal to new light. AC. New AC. And security system. New security system. Okay, so we need methods for turning on and off all the devices. So public void turn all on. So we refer to light turn on, AC turn on, and security system on. Let's actually rename this. Let's deactivate. Deactivate. Okay. Now the same method for turning all off, lights off, AC off, and security system deactivate. Okay, let's create a main class with main method. So create smart home facade. And then we can call facade turn all on and facade turn all off. Let's run this. So lights are on, AC is turned on, and security system is activated, and then lights are off, AC is off, and security system is deactivated. Okay, so this was the last task. Thank you for watching, and I'll see you in the next one.